The period is the time frame. Like this is one period, a science period. So the time set out for science today. Okay, so what is period when it comes to waves? It is the time taken for one complete wave pulse. The time for one complete wave pulse, and that is measured in seconds. Wavelength measured in meters. Right, then we have frequency. The symbol for that is a F, a lowercase f. That is the number of wave pulses per second. Now, from now on until the day that you pass away one day, if you hear the word per, you must think of divide by. The word per is divide by. So if I say, all right, we have, let's say what is something we all want right now. Let's say I have 100 liters of Coke, not cocaine, Coca-Cola. All right. How much will each child get in this class? We have 4, 8, 12, I count as one. So we are 13. So then you're going to say 100 divided by 13 gives you 7.69 liters. Okay, so you're going to say 7.69 liters per person. So that means per divide the 13 people per person. So basically we divide it in our head. Sharp? Okay, so if we say frequency is the number of waves per second, then we say frequency is the number of waves per time. Okay, now this hashtag here, the original meaning for hashtag is not to tag something on Instagram or TikTok or wherever. Hashtag actually means the number of. Or number. So sometimes you'll see they say hashtag 1, then it means you are number 1. Okay, so the number of waves over the time or over the period. Or if you look on your data sheet that I've handed out to you, I think it's page 26. These things, I think I said you must take them apart. Did I not say that? I did. Okay, well, take them apart. Yes. And at the back where the front, somewhere where you get easy access to it. Put the two things in separate sleeves. Back, front, doesn't matter, so take them apart. Put them in separate sleeves. Where's your blue file? When are you going to get one? Because I said I gave you until the end of January, which was Wednesday, last week Wednesday. Alright, so take them apart. And I'm now on page 27. Okay. On page 27, about halfway down, so put them in separate sleeves. Separate sleeves. Like this. At the back, in the front, I do not care where, somewhere where you will have easy access to them. Page 27, halfway down the page, there is a table with a heading that says waves, sound, and light. Got that one, telephone. Alright, there where it says wave, sound and light, look at it, there's 3 formulas there. Okay, one of the formulas looks very similar to this formula that says F is 1 over T. Yours just says T is 1 over F. Yes? Let's go see that one. Thank you. Okay, so it's the same formula, it's just a bit rearranged. Okay? So that formula is on your glass sheet, meaning you do not have to memorize it. Okay, so the one that's on your formula is T is 1 over F, but you can just rearrange that to get F is 1 over T. Yes? Then it would be T, so if you swap these two around, it means you must swap these two around. What you do on the one side, you do on the other side, you get that, which is that. Alright, so frequency is how many waves you have in a certain time frame, or the time taken for one wave. And frequency is measured in hertz. Hertz. That is what you have for your radio stations. What radio station do you listen to again? 90. Do you listen to radio? Never. No one. No one, no one. Huh? What radio station do you listen to? 94.7. So that means 94.7 hertz is the frequency for that radio station. Okay. Right. Then we are going to do a quick activity before we do something else. It says the vibrations or oscillations is another word for vibration. A vibration or oscillation is repetitive, something that's over and over again, to and fro motion. Where did I put that? So if I have this here, and right, and we go back and forth and back and forth and back and forth. This is a to and fro motion. This is called a vibration or oscillation. Okay, when you go back and forth, oscillation. And the thing that we have here is a pendulum. A pendulum is if you have a piece of rope or string and there's a weight at the bottom of it. It's called a pendulum. Alright. So it says there the simplest form of vibration of motion is a pendulum. Okay, so here is an example of a pendulum. We have a weight at the bottom of a piece of string. And you see there that they originally had the weight there, and then they let it go, and it went up the way there, and then it'll go back, and alright. Now from there, from that type of motion, they drew a graph. Okay, you can see it's a position time graph. So if we look at A, their position of A is at the top, the highest point. So there's at the highest point that we call the crest. Do you remember that? And then it goes down, 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 down until it gets to D. And then from D, it goes up until G again. But then it goes in the negative direction. So this is considered the positive direction. This is considered the negative direction. Back and forth, back and forth, back and forth. Alright. So if the pendulum was stationary, if it was at rest, then it would just hang there. That position is D. So we can see there that D is considered the equilibrium. It's called the equilibrium or the rest position, the original position. Okay, sorry, something I forgot to say. So A is the crest, and we see there that G is the trough. Okay. Right. Now let's read some questions. It says there, from the position time graph, choose A to G. What is the amplitude of this wave? Genevieve, let's start with you. What is the amplitude? What's the definition of amplitude again? Okay, so the maximum disturbance of a pulse from its rest position. So there's the rest position. So it's either from D until A or from D until G. Okay, so we're going to say that. So from, D. D until A or from D until G. Either in the positive direction or the negative direction. Okay. And then they ask, now I must think again. Oh, flip. I'm going to say Carabello. Carabello, what is the equilibrium position? It is D. Then highlight one period on the graph. What is the period again? It is the time for one wave. So they basically ask highlight one wave. Okay, now here you can choose, because one wave can be anything. It can be from A to A, or it can be from B to B, or it can be from D until D. So you can choose whichever one as long as it's one wave. So I'm going to choose from A until A. My question to you, Karabu, is could I have highlighted from this B to that B? Why not? So my question to you is, could I have highlighted from B to B? Hukom. Sorry? Meaning what? Are you trying to make a wave? When you say they are not the same, I think I know what you mean. They are, or the next thing that happens to them are not the same. Yeah, sure. So they are out of phase. So this B, the next thing that will happen to him is it will go up. This B is it will go down. So they are out of phase with one another. And we say they're one wave. It's the distance between 2 points that are in phase with one another. Meaning the next thing that happens to them must be the same. So you can't go from that B to that B, but you can go from that B to that B. Because this one will go up next and this one will go up next. Chop? Okay. Then they ask, what is the trough? Le Sejo? G. And Talifu, what is the crest? A. Then it says, if it took 4 seconds to complete one wave, what is the period of the wave? Doubling. Yeah? Oh my goodness. Omulemu. Doubling. Sizwe. Sizwe, what is the period of the wave? If they say 4 seconds for one wave.
4 seconds for one wave.
Yeah. So what is the period? Go back to what is the definition for period? No, give me the definition for period is?
The time taken for one complete wave course.
Okay, so the time taken for one wave. So what is the period? Don't overthink it.
4 seconds.
4 seconds. Then my question, and this is a calculation question, what is the frequency of the wave, Amara? So frequency, if you look at the previous page, to calculate that, is 1 over t. And t is period. 3.25. Whoa, yes. So it's 1 over 4, which gives you 0.25. And the unit for frequency? Hertz. Alright. Then the next graph, you do not need to know that well. Okay? But what you basically have there is, it's the same scenario. So the same pendulum going back and forth and back and forth. But now we have a velocity time graph. Velocity is the same thing as speed. So velocity is the same as speed. So how fast does it move? Okay? So if we think here, I'll do this. Where does it move the slowest? When it's at its highest point or at its highest point, right? Then there's like a split second where it's stationary before it goes down again. So where does it move the fastest is here. Because here it's slow, goes faster, 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 fastest, slow, 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 slowest. Fastest, slow, slow. Right? So here we see, we said at A, it is the slowest. So at A, the velocity is 0. We said at D, it moves the fastest. So at D, it is the highest value. Either positive or negative, depends on the direction it's going. Alright. The next page I am going to skip because we are a bit behind. So the next page is not that important. I want to go to page 5. Okay, so we have spoken about transverse pulses. Now we're going to go to transverse waves. And remember, anything in a block is a definition that you must know word for word. Okay, transverse wave. A wave in which the particles of the medium vibrates at right angles, or you could say perpendicular to the direction of motion of the wave. Okay, now we have discussed this fully and quite a bit. Okay, so we've done a pulse, but now we're just thinking about a wave. Okay, particles move up and down, wave moves to the left and to the right. Okay, so a transverse wave, and they are said in brackets, so brackets is not part of the definition. Transverse wave is a succession is one after the other, of transverse pulses. Okay, and then I give you example there, water, light, radioactivity, cell phones, all examples of transverse waves, and you see there the rope goes up and down, and the wave goes forward and to the left. Okay, now we're going to get to the speed of waves. Speed of waves. There in the little block is the definition. That is the distance traveled by a point on a wave per unit time. The distance traveled by a point on a wave per unit time. Now I said, really, when I say the word per, you must think of the word per from now on until the day you die. When I say per, you say do I feel like I want to be one of those cheerleaders? When I say per, you say divide. Per, divide, per, divide. Right. So, from this definition, we must be able to get the formula. Okay? Because it's distance per time. Okay. Now, unit time just means it depends. What are we looking at? We're looking at how far does light travel in the universe? Do we look at how fast does a radio wave travel? How fast does a gamma ray travel? So per unit time, we can refer to hours, seconds, light years, what. Okay, so unit time just means any unit that is applicable in that scenario. For us, what is applicable is we are going to work in seconds. Okay, so distance per time. The symbol for distance is x. X, distance, per divided by time. Distance per time. Okay, that is the formula to calculate speed. The distance per time. So the definition must help you with the formula, or the formula must help you with the definition. Okay. Right, so here you see there's that delta thingy-majingy again. You can ignore that delta and that delta for the time being. Quickly look again at your data sheet, please. There at sound, waves, sound, and light, I think. Yes? Do you see that formula there? Is that formula present there? No, you lie. We are happy about the wind because wind brings rain. As you guys listen, this time it's bringing it. I'm proclaiming it over us. Right, do you see this formula on the left hand side on your data sheet? No. So what I want to tell you is that formula is not on your data sheet. So you have to go study it off by heart. So right next to it, study, not on data sheet. Not on data. Okay, right, where are we with our questions? To me. What do we measure distance in? Look there at the bottom. In meters. And Asina, what do we measure time in? What's the unit for time? Seconds. Right. Do you remember from the first chapter we said if we have meters divided by seconds, we can rewrite that as meters per second? Yes? So the unit for velocity, for speed, is meters per second. Meters per second. Right. So if you struggle to remember what is the unit, go look at the formula to figure it out. But we have another formula to calculate speed. So we have two formulas. Now this formula is on your data sheet. You'll see it there. Again, V stands for speed, F stands for frequency in hertz, and lambda is the wavelength in meters. Okay, let's practice these formulas. It says, the tsunami that caused chaos in Japan in 2011. Now, 2011, you were 3 years old. Yes? 2 years old, 3 years old. Do you know what happened? There's a movie on it. The tsunami, I can't remember what's the movie's name. Do you know what is a tsunami?
Yes.
All right. To me, explain to the class what is a tsunami.
It's like the water layer.
Do you know what she meant? No, that's not a good explanation. Lesego, you also said yes. What is a tsunami?
I'm not maybe said yes.
You are the one. I looked you in the eyes and you said yes.
I don't know what explained another word because it's the I don't know it's the dates I don't
Who has geography?
know.
And Genevieve, please explain to the class what is a tsunami.
Tsunami is seismic activity on the ocean which basically causes the water to move and waves will pick up speed over time.
Alright, so I couldn't clearly hear what you said in the beginning, but basically the place of moving, it is an earthquake. and then it causes the waves to move, but it moves really, really, really fast, and then it washes away everything in its path. Okay, now we are going to calculate. So this tsunami went over a lot of islands, and people's homes were gone, and it was very tragic. Okay, so it says there, it moved 120 kilometers in 30 minutes. 120 kilometers is more or less from here until Joburg. How long do we drive from here to Joburg? Hour 15, depends how fast you drive. Now, imagine driving that in 30 minutes. Okay, so that's very, very fast. Okay, now they ask, what is the wave's speed? Now, from now on until the day you die in science class, when you need to do a calculation, you're going to start with an info table on the right-hand side. You're going to write down all the information that we have. Okay, they speak here about 120 kilometers. Asina, did you answer something? What did you answer? I can't hear. What? That's true. Umulemu, first of all, 120 kilometers, what symbol goes with that? What information are they giving us? Say again? Is 120 kilometers 30 minutes? Like, I'm asking which one of these symbols goes there. Say again? Velocity.
Delta X.
Thank you very much. Okay, X, I said you can ignore the delta. But, Omulemu, do we work in kilometers? We work in meters. How do you go from kilometers to meters? By what? 10 to the power of? 3. Okay, so this is not something I'm going to tell you. Step 1, change kilometers into meters. That is something you need to know. Alright, then next piece of information they give us there is 30 minutes. Doubling. What are they giving us? Time. But do we work in minutes? We work in seconds. How do you go from minutes to seconds? No tens. How many seconds are there in 1 minute? 60. So you're going to multiply by 60. Are you guys writing down? Are you multiplying? So that's 30, you're going to multiply by 60. Right. Then they ask what is the wave speed. So they ask for V. Now you're going to look, alright, which formula do I need to use? Obviously the first one there. So we're going to say V is X over T. Okay, that is 120 times 10 to the power 3 over 30 times 60. You could have just written 120,000 over 1,800. That doesn't matter, same. Then we are, Genevieve, back to you. Yes. Here's Jenna. Are you using the fraction button? Okay. Sorry? No. No, I don't want it in fraction form. I want like a full answer. And the unit? Wait. Alright, now let's just think how fast that is. Carabello, how tall is a door? No. 2 meters, 2.1 to be exact, but more or less 2 meters. Okay, right. So, how many times will 2 meters go into there? 33 times, more or less. Okay, so imagine on your head, take that door and go 33 doors. Up, up, up. That is really high, right? Now, that length, 33 doors in 1 second. That is how fast the wave moves. 33 doors, it says 66 meters per second, meaning in 1 second. That's very fast. Alright, next question. It says, it is observed that 8 waves pass a point every 4 seconds, and the distance between 2 consecutive crests is 400 millimeters. What is the speed of the wave? Okay, now you're going to draw the wave. Okay, it says 8 waves, so we have 1, 2, 3, 4, 5, 6, 7, 8. 8 waves. So they tell us from there to there is 8 waves, and that takes us a total of 4 seconds. Not art class, not EGD. Quickly, quickly. Seconds, and then they say from one crest to the next, 2 consecutive crests, meaning from one crest to the next, that there is 400 millimeters. Now you can see I wrote this down in 2 different colors because this information goes together and this information goes together. Okay. When they say 8 waves in 4 seconds, Karabu, what are they basically telling us? What information are they giving us? Go back to your definitions. They give us a certain number of waves in a certain time. A certain number of waves in a certain time. Yes, what are they giving us? The what? The number of waves in a certain time. So what are they giving us? The frequency. So with that information, they say frequency is, the number of waves is 8 waves in 4 seconds. So they give us the frequency is 2 hertz. Right. Then they give us, so they're basically testing your definitions there. Because they're applying that definition and they're giving it values. Alright, let's say who? Then they say the distance between 2 consecutive points is that. What information are they giving us there? Let's say who? Distance between 2 consecutive crests is that. The wavelength. They're saying the wavelength is 400 millimeters. But, Telefu, millimeters. Do we work in millimeters? We work in? So how do you go from millimeters to meters? We just did a whole chapter on that. We practiced it. Go back to that chapter. -3 because you can divide by 1,000. Millimeters to meters, that way you're going to the right, so you minus. Okay, so we have frequency, we have lambda. They're asking for the speed. All right, so speed, that one there, V, so we're going to use the second formula. V is F times lambda, frequency is 2, lambda is 400 divided by 1,000 is 0.4. So in your head, sees where? 2 times 0.4. Yes, easy peasy. What is 2 times 4? So what's 2 times 0.4? 0.8 meters per second. Sharp? Okay. Right. So grade 10s. Your okay, I'm going to check your homework now and I'm going to give you homework. Your homework was that writing out, yes? So your homework is page 6 in your notes. You can do it on the notes if you want to, or you can do it in your writing book. There's enough space in your notes if you want to. Then I also want you to please bring this book with for tomorrow. Sharp. Just this book.